started? All right. We'll see. It'll pop up a little bit. So today, thank you. Objective today is to work with more exponential logarithmic equations. There are a few more rules. So in order for us to achieve today's goal, we're going to use we're going to solve equations that have like bases. I kind of touched on this, but now this is like a formal here you go type thing. Like bases to solve exponential equations. We'll use logs to solve exponential equations. You will use the definition of logarithm to solve the equations, which is pretty cool. Use the one-to-one property for logarithms. If we get to the last two, cool. But definitely I want to make sure we cover the first three. The last two kind of help you out with when you're doing the word problems. But if you understand the first three bullets, then we should be okay. Make sense? And we are good on the recording. Okay. Oh, that's not the right notes. Where's my notes at?
Those are the wrong ones?
No. On this one.
Oh.
I'm on chapter 5, chapter 3. I know. No, we're in chapter 4. I mean section 4. Ah!
We're on section chapter 3.
Leave me alone. Let me get through this on my own.
No lessons.
I will make it, I promise.
That's what I'm saying.
Thanks for your support. All right, let's get started. Now, whoa, I'm missing a slide. Oh no, you guys were recording this, right?
Yeah.
I mean, you guys were writing this down? Is that the slide we were on?
No.
Did I just put it on?
Yes.
How did that happen?
I don't know.
All right, anyways, let's look at the first rule. Let's look at the first, I know, I'm sorry. Once I get this cold out of me, I will function. I wasn't going to come in today, but I have so many obligations and duties.
You can miss one day.
No,
Yes.
you guys already know when I woke
Miss
up.
Wednesday,
This is
there's no
what you
lesson.
no, this is what you should have done. Not come today. That Wednesday when we're supposed to have that free day.
We could
We could've made it up.
done a lesson.
I feel like if I miss a day, we get behind a week.
We really don't.
I know, but that's how it feels. Let's talk about this first rule. How about we talk about this first rule?
Yeah.
This first rule is saying, hey, you know what, guys? If you have two powers that have the same base, then that means that, and it's an equation such as this, then that means that the two exponents have to be the same. And like I said, I think I mentioned this before. If I had 5 to something, and I said that equals 5 to the 4th, then what should the other equation be? It should also be 5 to the 4th, right? Because we're saying these both things are the same. So, if the bases are the same, then the exponents have to be the same. Therefore, in this case, I can make this equation saying, oh, x equals 4. Make sense? Questions there? No? Cool. All right. Oh, sorry, did you want that back? If I have 5 to some exponent, and I'm saying that equals 5 to the 4th, then that means that x is also equal to 4. Okay? And I just did all this process with that blue part. Okay, so all these steps are right there. All right, so let's try that out. You guys ready? Here's this example. Let's solve this. Oh, Mr. Munoz,
Oh, that'll be 5 cubed.
those aren't the same base. You can't do this.
5 cubed.
X equals
Miss Price, you said yes you can? How so?
Yeah, you can.
Ah, here we go. If they don't have the same base, thank you. I want to convert them in such a fashion where they do have the same base. So I can rewrite 125 as 5 to the 3rd, right? That means that now I can solve for x because 3x minus 6 has to equal 3. And then I just use some algebra at this point, don't I? So I'm going to add 6 to both sides. For a high five, which property did I just use? Sonny, you better get this one.
Addition thingy of commutative equality?
Yes, it's the addition property of equality. I've added to both sides the 6, and that maintains balance, aka addition property of equality. So now I've got 3x is equal to 9. I'm going to use the division property of equality, and I find that x has to have a value of 3 in order for that to be true. And here is the whole page. board. I've got the whole page. What's up? Sounded like a really good question.
Hold on. Oh no, never mind. No.
Oh,
Another
that's even
question.
better.
I got it.
Awesome. I'll move out the way. Over here, we're good. Miss G, Yahtzee, not so bad, huh? I can do that. All right, ready to try again? All right. No, because, well, it kind of does. Because in order for me to use, how about that professional courtesy? The 5 does matter because if I look at the top, these are not the same base. Therefore, I can't do anything here until I have the bases be the same. So then that's when I converted this to 5 to the 3rd. Then from there, well, the question really is, what is the ultimate question? What is x? If I can answer that without ever looking at the bases again, why not? Okay? Cool. So, you try. And I'm gonna get my dojo here. What does your dojo do? It's gonna pick somebody randomly.
Oh no.
It might be you. Maybe.
This is hard.
Well, that's true then.
Can I use my calculator?
Yeah.
Just because if you're good.
Your calculator won't do it for you.
No, I know, but just like try.
Okay.
This is
Oh, yeah.
triple BS.
Triple BS?
Yeah.
What? A minute ago you guys were like screaming out
Yeah,
answers.
because the other one was easier. This one's harder. Hold on, I got it.
Alright. That's the attitude.
And we're over here like, this is triple BS.
You got it too? You got it also.
I got expnential.
You didn't go to ASD? So you got ISD? For ID? Wow. Yeah?
Yeah, I was on my way to get my
What'd you get? Negative 12? You got negative 12? What? You got negative 12? Oh, wow. So it looks like it might be negative 12?
Yeah.
I didn't say it was wrong. I'm just saying it looks like it might be. All right. So let's not even do it?
No, let's do it.
Do it.
Do it. Okay. So, remember, I need them to be the same base. Correct? So here's what I'm going to do. I'm going to do this first actually. This will be my 8 and this will be x plus 2. Let's go with that?
Yeah.
And this will be my 4. This will be x minus 3. Well, I'm just removing the bases and putting parentheses there. Because I'm thinking to myself, is there a way for me to express both 8 and 4 to have the same base?
2.
It would be 2, wouldn't it?
Yeah.
So how would I express 8 with a base of 2?
2 times 2. 2
So it'd be 2 to the 3rd,
Yeah.
right?
Yep.
And then how would I express 4?
2 squared.
2 squared. I'll pause there. Make sure you process that in. And hopefully you guys are watching what I'm doing. No?
2 times it's 2 times 2. Yeah.
Cool?
Okay, yeah.
So we're good?
Yeah.
Now, at this point, I'm going to use my power rules. I have to, in order to figure out what the exponent here is, I multiply them, don't I?
Yeah.
So this is really 3 times x plus 2. And because they have the same base, then this side has to equal 2 times x minus 3.
Where does the
What? Those are the exponents from the base that you would multiply to the.
Just solve it now. Got 3x plus 6 is 2x minus
They're
3.
the bases. You don't. The 2 don't matter.
they don't matter?
Yeah.
Not really.
Oh, okay. That's
They don't
why.
really matter at this point because what I'm after is x, aren't I?
Yeah. You're trying to figure out.
So what do we have here? Take 2x away.
It
That's
should
gone.
be 2x minus 6.
minus 6.
Oh, thank you. I know.
You like how we're just like so.
I'm sorry. X And if I take away 6 to both sides, then we got negative 12. And there's your problem.
Okay, I think I can do this. I'm kidding.
Everybody's talking, but all I hear is meh, 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 meh. Like usually I can hear a lot of it. I think it's the cold in my head. Like
That means we should not leave your
peanuts.
Charlie Brown.
Charlie Brown peanuts. Yeah, Charlie. I know you're saying something.
Why don't we just like do half of the lesson today?
I need my ears to pop.
Like
I've tried yawning, you know, like
No, like hold your nose and like blow. That makes it worse.
that pop.
Sorry,
That,
brother.
that makes it worse for me. For me, if I yawn hard enough, they'll just go pop, pop, and I can hear again. Chewing gum sometimes help,
What
but
about the nose thing?
I can. My nose hurts too much. I think I've got like scabs growing on the inside where my.
Yeah.
All right, I can change the slide. Yay, change the slide. Please put your phone away. Go ahead and take a picture of this, I guess. Unless you want to write it out now. Remember, these are on my math lab, so if you need to go back, you can. They're asking you, they're giving you pretty much the steps to solve exponential equations. This is what really matters here. I'll go and circle that for you. That these are some of the methods that you're going to use. There will be times when you're going to want to introduce natural log or log base 10. Yeah, there's just some methods for kind of solving these. Okay?
Yeah.
Unless I'm not, then I won't be here. But I'll be here unless I'm not.
Well, how are we gonna know when you're not?
When you see my door and it doesn't budge, you will know I'm not here. Sorry. What? I can't hear, so I'm.
I didn't say anything bad, I just said it like
Where's my handy dandy calculator? Oh, I'm looking for hot pink, but it's covered in my black cover. Shame on me.
Maybe like a mile. I do it every night.
Okay, can I move on?
Yeah.
Okay, here we go. Here's a problem for you. Here's the beauty of logarithms. There are many ways to solve this one. How you do it is really just going to be up to you. They've given you some techniques that you can kind of try to do, but you don't have to. Okay? So I'll just do a few up there for you if you want,
Yeah.
and then you pick whatever you want. Alright, just get good at it. Now, here's one thing that I can do. I know that I can change this over into logarithms, right? What I'm really asking is, some log with a base of 5 is going to give me 134, right?
Yeah.
So I can do that. I can actually throw this in my calculator using the log base feature, correct?
Yeah.
And I can get the answer that way. Or once I've done this, I can go into the, or I can go log 134 over log 5, and I can throw that into my calculator, right? Or, even before all that, I can introduce natural log. I can say, hey, ln 5 to the x is equal to ln 134. Reason for that is because I can take this x, kick it to the front, correct?
Yeah.
So I got x equals ln 5 equals ln 134.
Then you just divide them.
Divide both sides by ln 5. That's going to give me x equals this quotient, which was actually the log base change formula to begin with. Because remember, once I do a base change, I can go to any base I want, correct?
Yeah.
So, any method that you've taken, any route, as long as you follow the rules, you should be able to score.
It's like 3.0.
Play cool what?
319.
Like he's the best.
Oh yeah? I have one too. I won't tell you what they're for, but I have them.
But
Exactly. But it's what do you call it, putt-putt?
Oh, you scared us.
Why? No! I'm not a child beater. But it's not something you brag about, right? It's like, hey, putt-putt champion. And I'm actually pretty terrible at it, so I'm not bragging about it. Questions on this problem?
no, don't move though.
Sorry? ln is the same thing as log with a base of e. ln is log base e.
Which is 10.
No,
No, E
log
is
by
2.71.
itself has a base of 10.
Log is base 10.
Don't move anything.
Are you updating your status there, Hello Beba? If, thank you. Real quick, if they're looking for exact answers, this one or the ln version will work. I'm not sure if this one will work, but technically it is. These are exact solutions. If they want an approximation, then just go ahead and enter in your calculator. And they should all give you approximately 3.04.
Yeah, you get
Every
the Yeah.
Every one of those methods, yeah. Because that is what that's worth. I mean, x would have to be approximately 3.04 in order to make this true. Make sense?
Can I try it?
See, because if you think about it, 3 would only put you at 125, right? And 4 will put you way above that.
Yeah, see.
So it's got to be something between 3 and 4. And in this case, it's 3.04.
I just did the actual.
You guys ready to try on your own?
Yeah.
Queenie? Queenie?
Actually, that'd be a little hard because I'm not
Here you go. You try. Any method you want.
So it's 10 VX equal to.
Do you want approximation? Is that what you want?
It's up to you. Approximation would be fine at the end.
Oh,
What is that?
Wait.
Is that a word?
Yes. How many decimal places are
Do
we
you
going to?
want us to round up to?
2 decimal places? Is that good?
Sure.
What did you get?
10 to the 10th 100? I don't want no scientific notation. Oh.
Just use log base.
Yeah, but I just want to be fun. I'm very goofy.
Two extra threes.
What is 1E10?
She turned 17, I turned 16. We're exactly 1 year apart.
What?
Is it 80?
That's really old in this classroom.
Not
See,
really.
this is what happens when you try to be fun.
Yeah, oh.
Well, this one's for me. That's not the way I'm going to show you how to do it. But here's what I'm thinking. See how I can split this up? That's it. I'm not going to pay attention.
I'm already paying attention. Go ahead. I'm paying attention.
It's not 80.
Well, if I introduce log, then now I can take this 8.
So what they smoke?
Yeah.
No, but it would be log 8 as well, wouldn't it? That's why.
Yeah.
Yeah, never mind.
He's like, oh, it's not fun anymore.
No, it's not doable at that point.
Yeah.
It's not doable at that point. What'd you guys do? Did anybody use log?
I did.
Log 10x, log 8,000. That makes this just x. Log 800, or sorry, 1,000. That is exact, my friends.
I didn't do that. Wait, what?
Wait,
Oh, that's what I was thinking.
I knew it.
Wait.
Because I put the log 8,000 over log 10, and then I was thinking that they would just cancel each other out because of the log.
Well, yeah, so once I introduce log, let me do this again slower. I already saw this 10, which is perfect because if I introduce log, what is the base on log? It's 10, right? And you remember that rule that says log base 10 to 10? That just becomes a 1, doesn't it?
Yeah.
So that's why I introduced log, because then that would just simply bring down my x. So now I've got log 8,000. So all this is gone, which means x is equal to that, whatever that is. But I have a log button on my calculator that I can just press and say, that's approximately 3.9. 0. Okay? Not too bad? Somebody pick a different method? Anybody?
I just did log base.
I did the log.
You went log base?
Yep.
Cool.
I did the log over
That's so easy.
Yeah, good.
That's what I did.
Pick one that you like. Get good at it. Okay? But just know that there's other tools there that you can use. Here, try again.
What is this?
Why for you do this to me?
Why are you trying to hurt me?
Hurt, man.
No, seriously.
It would be 21 or at 7 times straight.
What?
You have to multiply it.
Oh yeah, do
The
the
same base, so you'd make it 3 times 7 or 3. Hold on.
Oh, because the bases no matter what we say, right? Okay, cool, never mind.
Yeah.
The thing is, you don't know your exponents.
Right.
So,
Yeah. But what your exponents would take. So you're just multiplying the base.
What happened?
but it depends what the exponent inside the base is, to multiply it to that exponent.
Okay, now you're just confused.
Yeah.
Am I just being a jerk now?
Yeah.
Yeah.
No, you gotta stop to because you're gonna get things like this.
Yeah, it's gonna suck.
It does.
Yeah.
It kind of does. You guys just want me to walk you through this? Anybody still trying?
Yeah, walk you.
Let me give you another few seconds. People are still trying to do this. Or did everybody already tap? I tapped.
I'm not.
Okay.
I'm still thinking. Hold on.
I got one more still thinking. A few more. Yeah. What'd you get?
Is it? What did she get? What did she get? That's not what I got.
Nice try, though. Let me see. I want to see what you did.
That's not right. Wait.
You know what? I'm gonna try something else. Yeah, because you have pretty much two exponential equations, and I have to just find a way to cross. So I think what you might have done is you actually did your equations. Go to graph. You know you're the only one that has to do that I know of. Costco in the big box.
You can't.
I went to the Asian market
Do
yesterday.
it.
To Lily's?
Yeah.
I love Lily's.
Alright, can you do the equation
Lily's is
now?
like
Bother you.
international. What?
She was just like, as soon as she said, she's like, I love
So Mika goes, I love it. You have scissors because I'm always struggling. Oh,
You know,
just
there's
kidding.
another.
I
There's
got
another. There's another.
I wish we had it. Yeah, I went to Boba and then I was like,
Bubblegum shrimp.
There's another one, a bigger one, on Broadway. It's called Arizona International Market, Supermarket, and they got whole jackfruit sitting out there just like plop, plop.
What was that one?
It's fun. But I love Lily's. That's my place right there.
Yeah,
Gotta get my QP or QQ. How do you call it? The little baby mayo with the little
oh
fudgy.
yeah.
It's like Chinese mayo or Japanese mayo. I don't know what it is, but it's called QQ or Q pie or something like that. Okay. It's got a little cute baby on it.
We've already went over this last year.
Yeah.
I remember we were
I
all
love
trying to
that.
figure it
It's
out.
good mayo.
Finally, we've been waiting for you.
Thank you. So let's do this, guys. I'm trying to find a way to make this work, and there's no way that I can take 3 and 7, convert them to similar base, because they're both prime numbers.
Yeah.
I can't mess around with those and try to convert them into some type of exponent. So the only thing I can do is try to introduce logs somehow, so that I can use my power thing, where I can take powers and put them to the front. Because then now I have something kind of semi-linear type thing, you know what I'm saying? With no exponents. So, I don't want to use log base 10 because it kind of gets a little messy, but I'll do the log or the natural log. Why was it going to do that? Sorry. So let's do ln. 3 2 to the x minus 1 is going to equal ln 7x plus 1. Because now these are logarithms, I can take these exponents to the front. So now I've got 2x minus 1 multiplied by ln 3. That's equal to x plus 1 times ln 7. Okay? And then again, just like before, right? I want to get all my x's on one side and all of the whatever's not on the other. So it's going to be kind of bleh, but let's do this. I'm going to bring x plus 1 by dividing both sides by, right?
What?
Wait.
Wait. Oh, never mind.
Wait, hold on. Wait, why did you divide by
Because I multiplied that.
Yeah, I kind of have to go this route, don't I?
Yeah, you have to in order to.
Unless I did a foil. You guys want to try to foil?
No, I wouldn't try to foil.
What's up?
Why did you choose to divide by?
Because I want to get ln 7.
Yeah, you want to get
I want to get all the x's on one side and all the ln's on the other side. But foiling wouldn't be too bad on that side. Because I'd be multiplying by 1. And 1 times anything is itself, isn't it?
Yeah.
So, can we try that first before I do my division?
Sure.
Sure. Let me try that. So I would get 2x minus 1 ln 3 is equal to x ln 7 plus ln 7. Right?
Yeah.
No, I would still factor out to the same thing.
Yeah. So like.
So yeah, maybe I don't want to do that. So let's go back to the division.
Yeah.
Okay, x plus 1. X plus 1. That's gone. I've got
Stop throwing Skittles here.
quit tossing the rainbow.
You're factoring this, right?
Yeah, we're just trying to get x by itself at this point.
After while you do this so I don't get distracted.
Good. That's not a bad idea.
What do you say? Wait, what's happening?
Wait, this isn't the right
We're trying to get x by itself.
I'm lost. My brain hurts. Don't look at it.
Hmm.
I'm so nauseous.
No, it's not gonna be a whole number. It's gonna be a not so nice number.
I got a weird number.
found the right. You zoom in. Okay. You see here, I'm trying to look at what. Oh, they did FOIL it out.
What the?
Yeah, they did end up FOILing it out. Because this would just put us in a circle. Because in order to get this, we have to multiply both sides by x plus 1, right? And we're back at square 1 up here. Okay? So we're going to have to do that distribution. It's going to be easier that way. So this would become 2x ln 3 minus, I got it, is equal to x ln 7 plus ln 7. Then I've got, yeah, because now I can actually move stuff around and take things out if I needed to. So let's see here. I'm going to get all x's on this side. So 2x ln 3 minus x ln 7 is equal to ln 3 plus ln 7, right?
Yeah. So was that? How would we do that though? Because they're not the same, base. Would you just subtract 3 and the 7?
Well, I want to get this x out first.
So would you divide by x?
No, because we have to get x by itself.
Yeah.
So I could. I want to try to factor out so that I can divide. Oh. Okay. So we factor out the x.
Yeah.
This will leave me with 2 times ln 3 minus ln 7 is equal to this ln 3 plus ln 7. And now I can divide 2 ln 3 minus ln 7. 2 ln 3 minus ln 7. And that becomes 1. So x is equal to all of that. Which would be approximately, what'd you say, Lily? 12.11. Yeah, you can.
Are you done?
Yeah.
She came in. Are you done?
Wait, did you actually?
Because we're not gonna run it.
I wasn't in the bathroom.
Hold on. Today's Yatsi's birthday. It's Greg's birthday too.
Greg, Julio, and Yahtzee.
We'll do it after this lesson.
Today's Yatsolio Day. Yazuri.
I was this close to being able to vote.
I am so, but I just didn't do it. I just didn't sign up.
Is the lesson over?
I don't know.
Gosh, dang it, dude. We have 10 minutes.
Okay, let's move on.
That took too long.
You'll also get these type of problems, guys. Please do not forget that logarithms are simply a re-expression of exponents. So sometimes the easiest way to get there, is to rearrange it into an exponent. That means 2 to the third gave me x minus 4.
Oh, so it's 12?
Yeah. So 8 is equal to x minus 4. Add 4 to both sides, and x is equal to 12. So again, don't forget the logarithms are simply a re-expressed exponent.
Oh my
Except for me,
god.
thanks a lot.
Sometimes the path of least resistance is to just go back.
The path of least resistance? What? We don't know her.
I feel like Mr. Munoz would be that teacher to make fun of people about math. Using like characters to I don't even know how to explain it, but I feel like you'd be the teacher to do that.
Be like, we need to take path of least resistance. Okay, get exponent.
Through the zone of proximal development.
Oh no, we're now entering the zone of whatever.
It's like one of the gaming things, but like
Proximal development. You know what the zone of proximal development is? 3 heads are better than 1. Or 2 heads are better than 1.
Oh.
It's just the research-based one. You guys okay with this slide? So try that.
This is different from what you just showed us.
Not really.
It's a little different from the last one we just did, yes. A little different.
Yeah, we can pass it on. Pass it on. See how far it gets. I don't get this.
Me either.
Oh, wait, what? I'm confused.
Just pokes it, buddy. And say pass it
Okay,
on.
so bring form back.
Behind you. Figure it out myself.
Thank you.
Is the base, so it'd be E
Also,
3x4.
also don't forget that logs are simply kind of like an operator.
Yeah.
And if I'm multiplying some log by 4, it really is just that. So if I want to get rid of this 4, the opposite of multiplying is 2. So I could divide both sides by 4, and this becomes ln 3x is equal to 2.
It just looks scary.
Now,
Yeah.
well, I don't divide it by e. I'm going to take it to the e power. Because this is a natural log, I'm going to do e ln 3x is equal to e to the second now. So that will make this, and I've got 3x is equal to e to the second. What's my last step? Divide by 3. And that would be my x. Okay.
Divided by 3. What's the
Wait, that still works.
Wait, that's our answer?
Yeah.
Whatever
Pass it on to Evan.
your answer would be. Pop socket.
Honestly, I ran out of hot pockets.
Yeah,
in
but
my
it
house
sounded
like
like.
2 weeks ago.
It's actually really
I'm going crazy.
Hey, if we made Casagram ones, would you guys buy them for $10?
What?
Like if they were Union High School one, pop sockets?
Yeah, I'd buy them.
No.
If you sold for less than $5.
I have a bucket.
Less than $5?
Yeah, Decca tried doing that. They tried selling them for like, what, $10?
Yeah, but that's how much one actually costs.
No, I say $5.
But they had to be good material.
Yeah,
They
just
had to-
$5.
7?
I think I didn't. They can't get it off.
Yeah. Oh, actually, you can
And
get it
if
off.
you try it, it breaks.
I think it would be better.
Then that will
Don't
always
break
work.
the
And
top
you
of
get
the
good at it,
Oh yeah, sure.
then you'll be able to take calculus, the graphics approach.
See, because
Don't tell anybody.
I mean, people would buy it if the design.
Okay.
Kind of case that I bought from friggin'
Try this.
$50. I need that.
Make it a pop print.
Try this, please.
I ran water underneath mine.
I'm gonna use this.
I ran water underneath one. And you got it.
I peeled off a lot of things off of mine.
And Shuki.
Sticky.
And Chucky.
Boys, hit him up.
Oh my gosh.
Hey,
Okay, there's a lot of instances. Why is it so?
because we're running out of time. Every single problem we've done, we've solved for x, correct?
Yeah.
There's one critical step that I never took. What was it?
Use a calculator.
To check my work.
Oh.
Take my solution,
And plug it in.
plug it back in, see if it works.
Me either. Is it risk it all or nothing?
Eventually, you don't want to risk, it's not all or nothing. Now, just a heads up. I'll wait. This is going to end up being a quadratic at the end. You'll get 2 solutions. If you just throw them in, you'll be wrong, you fool. And you just lost points.
That's simple.
One of them will work, one of them will not. So just, the point of this slide is, do not forget to check your work. Because it would suck that you did it right, but because go that extra step, you lost your points. That make sense?
Yes.
Alright, I think we'll stop there because
Woo!
I'm tapped out.
I'm tapped out too.
Hold on, wait, we're not doing this anymore?
I'm just gonna stop the recording.
I tapped out after we started.
No, not.